Lesson 109, making graphs and using equations of hyperbolas. Okay, the definition of a hyperbola is that it's the set of all points P in a plane such that the difference of the distances from P, which are your set of points, to two fixed points called the foci is a constant. And we will draw a picture of it and show you. So when we did the ellipse, it was the sum of the distances from the points to the foci was constant. For hyperbola, it's the difference. If we have a horizontal orientation, that means it's going along like the x-axis. The equation looks like x squared over a squared minus y squared over b squared equals 1. And the vertical orientation is y squared over a squared minus x squared over b squared equals 1. So in the ellipse, since we were adding, it didn't matter if we had the y squared over a squared second. In this one, since it's the difference, we have to put that one first because it will be bigger along the y-axis. The horizontal orientation looks like, it'll look like this. Something like that. Your foci are inside these. So if you take a point on the hyperbola, say right here, the difference between the distance between this foci and this foci would be constant, no matter where you put your point. Justin?
Up there when you're writing.
Yeah?
It's called foci. Is there like a 7 under that?
That's a comma.
Oh.
Sorry. And then, of course, the vertical orientation would look like that. There we go. And the foci would be in, yes, Tan?
Is this the thing where A is always the bigger one?
Yes. Well, A is always a bigger one than the other one, too. It's just sometimes it's under the Y if it's along the Y-axis.
I know, I was just making sure that...
Oh, it's the one where it always has to be first. So if it's vertical, the Y would be first with the A. The bigger one always has to be
How do you
first.
tell? So that's the equation for it?
Mm-hmm. Yep. Justin?
Can you explain again what you were saying about like how like the foci is like a point on it being equal to something?
Okay, so if you take the distance from the furthest foci from that point and subtract the distance to the closer one, that number, no matter what point you pick, so if I picked a point right here and I subtracted this distance from that distance, it'll be the same as if I subtracted these two.
Oh, okay.
So no matter where your points are, this distance
So it's kind
minus
of
that.
directly proportional? But like as like the length of one of them increases, so does the other one, so that it's the same answer for
The difference is
Yeah.
the same, so,
Wouldn't that
oh yeah,
doesn't that- It's the eccentricities.
yes, I guess so, but that's a little different than direct
It's
proportion.
like eccentricity and all that stuff.
Yeah, we gotta get all that down too. Yes, Grant?
Is this kind of like, so, an oval, cut in half, flipped around, an ellipse? flipped
Do you
around?
remember that, I can show you online, remember that, remember the, what's that, hourglass? When
Yeah.
we did the,
Synchronous put together.
yeah, and then we cut right down the side of the hourglass and it made the, that was the hyperbola. So it's, yeah,
That's right. How do you do it, Seth?
okay. And then the E is the same thing, 1 plus b squared over a squared, or c over a. The foci are at the points, negative c0 and c0. This, whoops, what the? Okay, wait. That's for the horizontal orientation. The vertices will be at negative a, 0, and a, 0. And then the asymptotes, check this out, I'll tell you where those are. Y equals plus or minus b over a x. So the asymptotes are these lines, are so cool. They go like right along here. So there's those lines that these are approaching. And same like right there, something or other. So there'll be those asymptotes. And then for the vertical orientation, the foci are at 0, negative c, and 0, c. And the vertices are at 0, negative a, 0, a. And then the asymptotes, y equals plus or minus a over b, x. And that's where you'd have these lines right here. Tan?
So after the E, you wrote equals C over A.
Mhm.
Is that equation the same thing as C over A?
Yeah. Then you could derive it if you want, but let's not right now.
Oh, I was just
Okay.
making sure.
Yeah, no.
So when you're doing, trying to figure out if it's horizontal orientation and vertical, how do you tell?
If you have the equation, okay, so if you have the equation, if the x squared is in the numerator first, before the minus sign, then it's horizontal.
Well, how would you know, like, before then? Like, if you didn't have the equation, they ask you, like, make it in standard form. Like, they give you an equation,
Oh, it's probably gonna already have your minus sign there,
yeah?
and maybe you'll have a bigger number here like we did with the ellipses, and you divide. So it's just whatever's before the minus.
Is the,
It's the axis that it's going across.
oh,
So the x would be here and the y there.
It would probably tell you the vertices. And like,
Oh,
it'd
yeah.
probably tell you the vertices. So
That's
you can figure
true.
out if it's horizontal or vertical, because if it's horizontal,
The
that
x,
number would be first,
yeah.
and then.
That's true. If they give you vertices, or same with foci, if they give you any of those, you kind of tell too. Yes, Carter.
When you're talking about the asymptotes, is that similar to like tangents on circles? Like previously we've
Duh.
talked about.
No, because a tangent on a circle actually will touch the circle at a
Well,
point.
yeah, but like similar structure, I guess.
It's 1 point off from a tangent.
Because Carter, an asymptote can never touch the line.
Yeah.
That's like the
Except for
that's-
evidently that one we did the other day.
Yeah, that's the definition of asymptote.
So like, you know, on the graphs that we do, and they have a vertical asymptote, and the graph just kind of approaches it, but won't ever touch it. It just gets closer and closer and closer.
Okay.
That's what it means, that it doesn't touch it. Okay, so the axis that contains the foci and vertices is called the transverse axis. So if it's a horizontal orientation, then the transverse axis is the x-axis. If it's a vertical orientation, then it would be the y-axis. Now, if you have a different center than the origin, you guys already can probably tell what it's gonna look like. You'll have x minus h quantity squared over a squared minus y minus k squared over b squared equals 1, where h and k is your new center. And then that would be horizontal. Vertical would be you'd switch the x and the y. We get to do hyperbolic geometry in just a second. I'm gonna turn the page though. Sorry. Hyperbolic. Can you guys say hyperbolic?
Is that the horizontal?
This is the horizontal one.
Okay, and
The vertical, here I can write it. The vertical would be y minus h squared, and then x minus k squared. And you guys know hk is their center. Yes.
So,
Yeah.
from horizontal to vertical or vice versa, it's just the inverse, right? Because you're switching y for x.
Duh. No.
No, not exactly.
Yeah,
It's
no,
like
no,
it's not
exactly.
It's not like a reflection.
Right.
It's more of your twist. It's more like
It's like a turn, you know,
Yeah,
like
it's like a 90 degree.
90 degree
I know,
rotation.
but you do
Yeah.
switch the x and the y, and that's how you do it.
But we're not, no, because when we do inverse, we already have y solved for, and then we switch.
So if we solve for y and then switched,
You could try it and see if you end up with this. I don't want to do it though, but
actually,
you
but
could
you
try
get
it.
the same thing, wouldn't you? Because
I'm not sure.
if you reflect it across, it'd be-
Okay, I have to do this
Oh,
after we're
yes,
done
sorry.
taping this lesson, because now you have given me a problem that I must solve. So we shall try that. We'll see if they're inverses, but I really don't think they are. Could be wrong though. It's happened. Okay, hyperbolic geometry. For any point on the unit hyperbola. So you know how we have a unit circle? We have a unit hyperbola. Which we're not going in real deep here, we're just kind of introducing it, okay? X squared minus y squared equals 1. This is the unit hyperbola. We call this, instead of cos of x, this is the cosh of x, because this little h right here, hyperbola. Oh, so equals, and this is how you find it. E to the x plus e to the minus x all over 2. Yes, it's that other e. It's the other e. Square root of 1 minus b squared over a squared. Yes, Tam?
So, is that the parent function for a hyperbola?
This is.
Okay.
Yes, for a unit hyperbola.
Isn't
Oh, yeah, that would
isn't
be.
Isn't the parent function for circle just
Yeah, yeah, you're right. X
X
squared
squared
plus
plus-
y squared equals 1. Yep. And I don't know how you say that.
How does so
Sin. I don't know. Sin. Yeah, sin. Something like that.
wait, Mrs. Berry?
Go ahead, yeah.
Shouldn't that equation just move? Oh no, it's the y is so off.
This is actually called the hyperbolic cosine, and this one's called the hyperbolic sine. You know, I've always said cosh, but you know what? I think you're supposed to just say hyperbolic cosine. And I think you're supposed to say hyperbolic sine, but I never wanted to say it all the way out, so I said cosh. Yeah, we're going to end the lesson there.